And starting off our deletes, we need to first search our tree to see if it's even in here. Because remember, if it's not, we're going to insert it. So we'll start off with an if. So we'll make a new method. We'll have to because we need to search our tree. If search root, we're going to pass in the root and we're going to pass in our key, does not equal to null, then we're going to delete it, right? Because that means it's something in here. We can hover over and click create method. It's made it a private and we have created it inside of here. Now we are going to have to change some of these parameters though, like this object. We're not going to return an object, we're going to return node. It is a search. We're going to change this to just root, and it's okay being as int key. And we're going to change all of this inside of here. Now let's go back to our delete. So if this happens, root is equal to, now we need to make an actual separate method where we're deleting. So we'll say deleting, and we're going to want to pass in the root, and then we're going to also want to pass in the actual key itself. So we'll hover over deleting, click create method. Now we want this under our search because it happens afterwards. So we'll paste it in here like this. We're going to change this to node, or I'm sorry, root, and all of this else looks good. And then we can delete this because we're going to need to write inside of it. So if it's not deleting, if it is null, that means it's not in there, and all we need to do is insert it. So we're just going to call the insert method. We're going to do insert, and then we're going to pass in the roots, and then we're also going to pass in our key. And that's it for this specific part of the delete. And now we need to search through our entire tree. For our search, we first can check two base cases, because we're going to need to make this recursive, where we recursively search the left and we recursively search the right. Our base case is going to be if our root is null, because if the root is null, that means it's not in here. And so if it's not in here, we'll break out of this if statement because it will be null, so this is not true, and we'll go into this else statement. So if the root is equal to null, or if our key is found, so if our root dot data is equal to the key, that means we're just going to return the root. And then if we return the root, well, we've either returned null or we've returned the key. Otherwise, we're going to go into this else if statement, and then we're going to say, well, we need to know how a tree works. So a tree, we have our root, and then we have the left, and then we have the right. More theory can be found in the playlist linked below the like button. But essentially, we have the lower values to the left, and then we have the higher values to the right. And so what that means is that in this else if statement, we need to see if our key is less than our root. Remember, this is the root. And well, if our key is, let's say it's less than our root, we are going to need to search the left side, right? Because the key is in the low area. So we'll say else if our key is less than root dot data. We're going to be inside of here, and we are going to need to recursively search this. So we're going to return the search, and then inside of here we're returning root dot left, because our new roots will basically be whatever actual leaf or parent node is right here. Whatever node is the next one, that's what we're going to be looking at. So this will kind of act as a root. Remember, this isn't the actual root, it'll act as the root because we have more that we need to look at coming down here or coming down here. And so we're passing in root.left, and then we're also still passing in our key. Now we're going to have the same thing if our key is greater than root.data, or we can say if root.data is less than our key. If this happens, we are going to need to search the right side. However, there is an issue. If we hover over this, we need to add a return statement for this whole thing because so far they're surrounded in cases. Well, this or this is the only other case that could happen. So it's safe to take out this if, and I'll just leave it as a comment right here so we can see what it's doing. And so that will complete our search. Now, if this returns and it's not null, we're going to need to hop into this deleting, where we actually go about deleting it. First is our base case. Remember, if the root is equal to null, we are just going to return the root. This is needed because we're doing it in recursive. Otherwise, we're going to say, well, else if our key is less than the root dot data. Again, remember, we're going to have to be in the left side. So we're going to recursively go through deleting, and then we're going to pass in our root dot left, and then we're going to pass in our key. And we're also going to do the same for the right side. So I'll paste this in here, else if, and then root dot data. If it is less than our key is greater than the root. So we're going to have to look at the right side. So let's just say that we have our roots, we have 2 nodes, and then we have our value right here. Well, we're going to go through here, and we're going to say that this is the root, and our key is greater than. So we're going to be in our second else if statement. We're going to go down here. Okay, so that means the new root is going to be this. Now, it's not the actual root, it's just going to be acting as the root in our code. And then we're going to pass this in as well as our key. And then we can see that our key is less than our root. So we're going to need to go this way. And remember, a tree has branches like this. So our key is less than, so it's going to be found right here. And then if this happens, we need to actually write an else statement for this, because we need to reorganize the tree. So we are going to have this else statement. We're going to be inside of here, and we're going to say, okay, if the root dot left is equal to null, then we are just going to want to return the right. And then the same thing, we're going to say, else if the root dot right is equal to null, then we are just going to want to return, this should be right, this should be root dot right. And then we're going to return root dot left. So we're going to return the opposites. And then we have to actually rearrange this once we get the minimum value. When we find this value, this is finding it. And then we are going to recursively delete it once it's in the minimum spot. So we're not going to recursively delete it actually. We're just going to call the recursive one time to delete it, and it will delete it. It'll make sense when we code it out in a second. In the same else statement, but underneath all this, we are going to have root dot data, and this is equal. We have to get the min value, so we'll do min value, and then we're going to pass in root dot right. And then inside of here, we're going to hover over and we're going to create this method. So private int min value, and we're passing in node, and it's going to be right. We need to go through this and get the smallest thing. And remember, the smallest thing is always on the left hand side. So at the beginning, we need to initialize our minimum value. So we'll initialize the min value to the root. Because if there's nothing in it, then our root is our min value. Or if there's one thing in it, our root's the min value. If there was nothing in it, we wouldn't be this far. I think it would stop a little bit earlier. It would stop right here. So assuming that there's at least one thing in here, because this would have caught it if not, we are going to do int min is equal to root dot data. So we're getting this, we're initializing at the root, and now we need to compare the entire left side. Because remember, looking at trees, the left side is the smallest side. It holds the smallest values. So we're going to have to do a while loop. And we're going to do while root dot left does not equal to null. So as long as there's something, we are going to be inside of here, and we're going to reassign min. Min is equal to root dot left dot data. So we're going to get the left value here, and then we're going to reassign. Okay, so looking over this, this should actually be right dot data, because we're initializing min with our right dot data, and we're going to compare it to the left side. So even though we have something at the far right, we know that it's not going to be the minimum, because like I said, everything to the left is the smallest. So even though we initialize it here, we're going to overwrite it if we have root.left. So minimum is going to be equal to root.left.data, and then we need to reassign root, and it's going to be equal to root.left. And this will eventually break us out of this while loop. We could probably do a for loop and just have this in the header, but this works just the same. Once we're done with this, we're simply going to return the minimum. And that is going to be it for the min value, and then we'll return it here. Now, remember I said that we're going to, after we do this, we're going to need to come back and we're going to delete. So we're going to do root.right, very right, is equal to, we're going to go to deleting, and we're going to do root.right, and then we're also going to do root.data. So those are the two things that we're going to be passing in. Our root.right is going to replace the node root, and then our root.data is just the key value, and that is going to be stored in root.right. So we go through deleting, we would do this, and then store it inside of here. Once we're done with that, we're just going to return our root, and that will complete our deleting method. And our minimum value will also be complete too. So just an overview of everything we've done so far. We've made a constructor, and this constructor is just reading the file in. Next, we have our delete method. So this is just going to check whether something should be deleted or inserted. If it needs to be deleted, we're going to come down into the search method. So we're going to pop in here. Actually, sorry, we're going to pop in here. And this is a helper for the delete. It's going to search through and see if our node does or does not exist. And then after we do that, we're going to need to actually go ahead and delete it, which is what this method is for. So we have our helper method for search that will delete a node and return what is left. Actually, it's not a helper method for search. It's a helper method for delete. And it will delete a node and return what's left. And then we also have our minimum value. We can't forget about that. It's a helper for the deleting method, which will get the minimum value. And that is how the deleting and rearranging of the BS tree, binary search tree, would work. Now we're going to move on to actually inserting. And that we have this right here. And then we're going to work on printing.